Dear learners, I welcome you back to another session of Research Methodology course for Tourism and Hospitality Management. Hope by now you got an idea about different statistical tools that we use in quantitative research. I just remind you from the very beginning we were talking about research methodology, different techniques, and of late we have seen the parametric and non-parametric tools that we use in data analysis. In the last module, we have gone in detail about correlation and regression and multiple regression. In today's session, we will be going through the advanced statistical analysis methods that is called confirmatory factor analysis and structural equations modeling. I will cover the introduction part of confirmatory factor analysis in the first part, and at the last we will be going through structural equation modeling. So structural equation modeling, we have parametric and non-parametric. The parametric one is called covariance based structural equation modeling, and the non-parametric one is PLS structural equation modeling, that is partial least squared structural equation modeling. Students, let us remember once again the process of doing exploratory factor analysis before we go to the confirmatory factor analysis. When we collect data, we have a large chunk of data, that items that we have to extract, we label them, and finally we identify the suitable dimensions, that dimensions as per statistical validity. From there, we go to the next phase that we call confirmatory factor analysis. So let us see the underlying assumptions and the fundamentals of performing confirmatory factor analysis. Confirmatory factor analysis, or CFA, is a widely used term again in quantitative research. Especially these days, we find many researchers use advanced statistical tools that starts from CFA and ends with model building. What does it say? It does. Confirmatory factor analysis measure the variable that represent the constructs. So in EFA, we extract the dimensions. So in CFA, we start with the theory and the constructs are already defined. Remember, in EFA, we are extracting the factors, dimensions. But in CFA, what we do? Already these constructs are identified from the theory. So we have to specify the number of variables and constructs that we use. For example, in theories like SOR, stimulus organism response theory, TPB, theory of planned behavior, researchers have already identified the items, they build the scales. So these scales have defined the constructs. In our research context, we will be trying to check the validity of this construct. So we start with CFA before going into the model building. That is the final part of this research. Please remember, in today's session, we will be going through the key points. I will not be explaining in detail. I will also demonstrate you how we can do it. To develop your learning, you may undergo any workshop on EFA, CFA, and structural equation modeling. My purpose is to give you an idea about how to proceed with advanced statistical tools when you do research. So what we do first, we have to define the variables and the constructs, what we call operational definition of the construct. Where do we get it? We get it from literature review. So when we have endogenous construct, that means independent variable and dependent variable. These constructs being given specific definition. So we have to use that definition and adopt appropriate items, and most of these items are measured as metric variables. Then we have to create the relationship in a diagrammatic form. This diagram is named as path diagram. So look at the diagram I have given here. You can find the variable AT1 here. Every variable, there is a error term attached with it, and the latent construct attitude is constituted by 4 major items. So these items plus their error, that finally defines or give you a meaning of attitude. So like this, what is attitude? Here it is a latent construct. So when we work, we have to get the operational definition of attitude from the literature. And the items we use here, it is already used in a scale. The scale we can adapt or borrow from other researchers. So this image looks rather complex or maybe like a drawing, but this is a diagram very easily you can create using Amos software, which comes along with SPSS. So what is the name of the software? Amos. Or you may use other softwares. There are other softwares also helps you to do this confirmatory factor analysis work. But I used Amos, and I will demonstrate you how you can also use Amos to create this diagram. Let us start with the operational definition. Attitude is a construct. INT, I shown here is interest, is another construct. MOT, motivation, is another construct. So each construct, they have the corresponding variables. In attitude, we have 4 variables, and in interest, another 4, motivation 3. So altogether, measured variables here mentioned 11. And these constructs also have interrelationship, and that relationship is indicated by a 2-directional arrow, that is mentioned here, covariance. So in simple way, now can you explain this diagram? As a young student, it is easy for a student to capture, the diagrammatic representation, or a PhD scholar is concerned. See, 3 constructs, its fitness as a construct and its interrelationship, we are trying to explore through confirmatory factor analysis. So what are the steps involved in CFA? CFA means confirmatory factor analysis. C itself says confirm, F factors. So we have to identify a model. And in the previous diagram, I have used 3 constructs, and you might be remembering the relationships. So then second aspect is unidimensionality. It's a very important aspect. What does it mean? That means all variables that should have one thing, satisfactory loading. Above 0.6 is mandatory. And second, these variables should not have cross loading. That means each variable should load only to that specific construct. One directional relationship, that you can say unidimensionality. Next is validity. We have few validity measures. One is convergent validity, and second one is construct validity. When we did EFA, I used Cronbach alpha, and that was showing the reliability of the scale. But when you use CFA, there are a number of other parameters which we have to check. When I demonstrate, you will have a better understanding of how to proceed with it. But to make it, you need a robust data. The data should be normally distributed, and there should not be any outlier in it. Next, validity is discriminant validity. Discriminant means distincting. The construct should be distinct from others. One is each constructs that covariance, the correlation between the construct should be low, and there should not be any cross-loading. If the correlation is more than 8 between 2 constructs, it affects discriminant validity. Then last here mentioned is composite reliability. So internal consistency of the construct. So in a nutshell, we can present these validity measures in a tabular form. So these are the fit indices. That means when you perform confirmatory factor analysis, you have to check a number of validity measures and the result should be within or less than the limits specified. The three different fit measures, one is absolute fit, second one is incremental fit, and the third one is parsimonious fit. In absolute fit, we can find the chi-square value. It should be, the p should be higher than 0.05, and RMCA, RMCAA, that root mean square error, that is 0.08, it should be less than 0.08. Then GFI, this is the value, goodness of fit index. These are 0.90 and above. AGFI, TLI, CFI, NFI. These are the incremental fit measures. All should be more than 90. And finally, parsimonious fit, which means the fitting chi-square divided by degree of freedom. Parsimonious fit, that measures the chi-square value divided by degree of freedom. It should be less than 3 when you perform the CFA to validate the CFA model. So normality, skewness and kurtosis, these are the two measures checked here. Kurtosis should be less than 7 and skewness should be 1.5 or less. Now these measures, what we call, these are the fit indices. So when you check the result one by one, you have to be very careful. Your values should not exceed the given value here. And in case of incremental fit, it should be more than the given values. So let me clarify again. GFI, AGFI, TLI, CFI, NFI. These values should score more than 0.90. And other measures like the error, it should be less than 8%. That is indicated here as 0.08. I will demonstrate how we can create a CFA model. Dear students, what you see in your screen is the output of EFA, exploratory factor analysis. What I am going to do is, I am trying to demonstrate how to use AMOS to develop a diagram that is for confirmatory factor analysis. Please go through it carefully. I am taking Analyze. It is integrated with SPSS software which I am using. See, I created a diagram like this. This diagram is borrowed from the previous one. I will open a new one. Okay. This is the interactive space for AMOS. You will find it is like a drawing panel. So I have to create a diagram. So to create the diagram, I will go back to EFA result. I am copying this rotated component matrix in which factors are given, and I am taking it back to the workspace here. There is a plugin tool called Pattern Matrix Model Builder. I am creating a diagram. See, very quickly a diagram is created. So for the convenience, I am deleting some measures because otherwise it is occupying the whole screen. Now you could see the three different constructs, that is attitude, and the second one is interest, and the third one was motivation. So I have named these constructs, and you can find here these are the variables measuring it. So once I save this file, I have to save the file. I am taking as an experiment. I have to calculate the CFA model. To calculate, see, once again I repeat, E1, 2, 3, these indicate the errors, and the variable loading will come here. Three constructs I have made. Bidirectional arrows, these indicate the covariance. Calculate, there is some technical problem, I will retry it. So now we are trying to, we have to upload the data file. That data file is factor. Okay, calculate. Now it is calculated. You will find the results here. We have unstandardized estimate and we have standardized estimates. I want to see the standardized estimates. So I have not given the indices to show. I have to give command for everything. I have to give the output, what output I need. So for that, the output, I need standardized estimate, squared multiple correlation, modification indices, correlation of estimate. This is the output I required when the analysis is done. See, when we look at, you can see the score, the factor loading that is mentioned against each variable 0.77 and the covariance value is given 0.59. When you move the cursor, it shows the value. That means attitude to interest, there is a correlation of 0.59. Interest to motivation, there is a correlation of 0.68. Attitude to motivation, the correlation is 0.72. The factor loading, as per rules, it should be more than 0.60. Look at here, the factor loading of this is low. And here also the factor loading is low, 0.55. Apart from this, we should know the output. The output is visible in a different window. In this window, you can see the model fit area. We can see the output like the chi-square value divided by degree of freedom. It is less than 3. The value is 1.715. P-value is significant. The p-value is subject to the sample size. So we can ignore p-value time being. Look at the chi-square divided by degree of freedom, that is within the threshold limit. Look at the GFI, AGFI 0.808, 0.706, CFI comparative fit index 0.798, Tucker-Lewis index, that is 0.739. When you go down, RMSEA, this is 0.125. There is something wrong with the model. This model is confirmatory factor model is not appropriate. In such case, we can correct the model using modification indices. This shows if you remove some items, how the output will be. So you can use modification indices and remove the items from the model. For example, I told you this is 0.31. So we have to remove the scoring which is very low, that is 0.31. So it reflects in deleting items. Like I delete this item. Now I have to give a parameter. Again I have to calculate. So the process is going on. I started with 11 variables. In the process I deleted one. And when you see the results, there would be some improvement. And in the next phase, I may further delete. Like I saw this variable is also should be deleted. Okay, again I have to do calculation. CFA involves the identification of a model which suits to the next phase of study that we call structural equations modeling. So CFA tell you your model, the model which you are going to work on is fitting into the context as per the given statistical threshold limits. And it is time-taking process, and you should also have a good database when you do CFA. We use different softwares to get the output. You may perform CFA analysis with a data set which you collected from the field and test whether it fit into that particular context. Now we will proceed with the next segment, that is structural equations modeling. Structural equation modeling, it tests the validity of the construct. A structural model, that term itself says the model which we design, the foundation, the structure, how proper it is, and it define the established hypothesis, because the purpose of a structural model is to test the relationship that defines a specific direction of relationships. So in this particular model, I have used attitude and interest. Does it predict motivation? You can see the arrows directing towards motivation. What does it mean? Attitude may predict motivation or interest may predict motivation. I want to test it. So when we design the hypothesis, we write that attitude influence motivation level, or interest influence motivation level. To make it one direction, particular direction, you can say attitude positively influence motivation, interest positively influence motivation. So that here in CFA, you find that these three constructs that are connected with the covariance and it tested. Here we are trying to get the hypothetical relationship with motivation. The procedure to perform structural equation modeling is, first you have to test the measurement model, means the CFA model, then test the structural model, the model which I shown you just before, and check the validity. If the validity measures are appropriate, you can say your structural model is valid. So I will demonstrate you how we perform structural equation modeling. I am using the previous model to demonstrate how we can perform structural equation modeling. I am dragging this to make a proper model. Now I have to make a appropriate design. Fine. Now drag again to make it appropriate fit. Okay, now I have to connect it with the lines which indicates the relationship. Done. Now we have to add an error term and the plugins name unobserved variables, that is done. Yeah. Okay, now I can save this model and run to get the results. I'm going to proceed with the analysis. Now you get a certain outcome, but see, first thing is the model should be valid. The confirmatory factor analysis should confirm, the measurement model. Here the outcome that you see, it just says the loading factor. To verify the model, you have to go minutely with the estimates, each estimate carefully, and the fit indices. The fit indices should be appropriate. Here the fit indices are not appropriate. So this model is just for a demonstration purpose only. So dear students, what we discussed in these few minutes, it will take almost 2 days to a week to get a complete understanding of performing confirmatory factor analysis and structural equation modeling for a beginner. I wanted to bring your attention that this kind of model testing will enrich your work and it will be helpful to progress in research. In the last part, I will be covering partial least square structural equation modeling. It is a non-parametric tool. Here we use a software called SmartPLS. SmartPLS is quite a handy software. In CBSEM, covariance-based structural equation modeling, there are a number of assumptions that include the sample size and normality of data, the type of variables, this all matters. But in case of PLS-SEM, these assumptions are not stringent. So let us see the software first and I will try to quickly show you a demonstration. This is how SmartPLS look like. I have subscribed this. You have to pay either for monthly or annual subscription. For a trial, you will get it free of cost. The visualization of the outputs are very interesting. Let me show you how it works. I am using PLS-SEM to give a name. Here I am giving the name experiment. Now I have got the data set, the same data I have used. I have to create the model. So I have to take some output. What are the items I use? For example, N, 1, 2, 3, 4. I brought it here. I have given this is attitude. So it already created a design. Same way, next 5, 6, 7, 8. I'm taking it here and I give here interest. And the third one is 9, 10, 11, 12. This is a hypothetical work. Just for your information, I am using this model. Now I have to arrange it. I can arrange it like this. Okay, now I keep it here. See how handy this work is. I have to give connect. It is connected. This also connected. So then there is something which is showing invalid. Let me correct it. 1, 2, 1, 2, 3, 4. Attitude. This is not working. The blue circles indicate it is connected appropriately. I want to run the PLS. So I just calculate it here. PLS algorithm, standard. Okay, just do the calculation. See, it shows you instant result. Here we have to use the criteria, how we can check it. There are certain criteria called constructor reliability and validity. We can check the Cronbach alpha, whether it is proper. The red indicates there is the Cronbach alpha, means the constructor reliability is not appropriate. Like same way you can check the discriminant validity. So it gives a easy understanding of how to proceed with PLSM. So students, again I am showing this is only for demonstration purpose. If you want to use PLSM in your research, you may undergo any workshop, specific workshop, so that you will have a better understanding of how to do it. Let me come back to the presentation. So partial least squared structural equation modeling, it's a non-parametric tool. We have seen non-parametric tool, the advantage is if you have low sample size, you can work with that. And second, you can work with categorical variables, and it can work with non-normal data. That means normality is not a stringent assumption followed in PLS-SEM. So PLS-SEM treat a measurement model, inner and outer model. It check the factor loading, constructor reliability, validity, whatever we have seen in CFA or CB-SEM, and the estimates, that estimates shows the calculated model strength, and it has two kind of model. One is outer model and second one is inner model. The validity measures I have shown here, which you may copy. And finally, let us conclude what we studied in this module. My purpose to show these tools were to orient you towards the advanced statistical tools. So as a student, you may be wonder to see these kind of tools or the use of these softwares to perform data analysis. We have learned about regression. We can do multiple regression at a undergraduate or postgraduate level, but at a PhD level, as tourism scholar is concerned, it is equally important to know the use of these tools to make your analysis appropriate. We started with CFA, confirmatory factor analysis. It confirms the theory, and we test the variables, we test the loadings, whether they are appropriate, so that we can proceed with structural equation modeling. And we used covariance based structural equation modeling in the beginning. And in the second case, we studied how to conduct partial least squared structural equation modeling, PLSM. And we have seen the demonstration of two different softwares, that is AMOS. The second one is SmartPLS. to study about the use of these tools and working with the data. With this, we will come to an end of the quantitative techniques used in research. If you have any doubts, kindly come back to me. Thank you so much.